Welcome, ladies and gentlemen. So what I'd like to do is kind of discuss with you what exactly are the zeros of a polynomial. And basically, the zeros of the polynomial can kind of come in with a couple different examples of way we like to look at them. And so one thing, when we're looking at functions or equations, the main important thing is we're still going to have our x-axis, right? And if we're dealing with an equation, we have a y-axis, or if we're dealing with a function, we're going to have an f of x, an f of x axis, a function axis. But basically, we have our input and our output, all right? Now, when we're dealing with polynomials, remember polynomials are going to be, we're not just dealing with quadratics, that are parallels. We're going to be dealing with polynomials that have, certain degrees. So there's going to be multiple times where the graph is going to cross the y-axis. Okay, you can have something like that, and then you can have, something that looks over there. Okay, so there's, based on whatever type of polynomial, you can see that when the graph crosses the x-axis, it's important for us to understand that y equals 0. For instance, the same thing over here, what you notice is that all these x-intercepts, that f of x equals 0. So where the graph crosses the x-axis, where our two functions cross the x-axis, notice that the output, right, that is equal to 0, right? Because, here you could say 1, oh, that's at 3. Well, 1, 2, 3, negative 1, 2, 3. So the value up and down of where they cross the x-axis is at 0, and that's very important. So hence, one of the things we're looking at is when we're talking about the zeros, basically you can think about that's when the output value of your function is equal to 0. And so what we're looking for is what is the input value when the output is equal to 0. Because you can see at all three of these points, my output value of my function is equal to 0. However, the input value is different for all three of these equations. Now, how do we kind of go about, equations? And basically, well, for instance, basically, if we have an equation y equals, 3x to the fourth minus 2x, squared plus, I don't know, 5, okay, or something like that. And I'm making up a problem, so please don't try to. But if we're trying to solve for this, basically what we want to do is if we're going to find the zeros, we're going to want to make sure our output value is equal to 0, okay? Then what we're basically want to do is we're going to want to factor this. Now, I'm just going to make up some problem, okay? I'm just going to make this up. X squared minus 4, and then, x squared plus 3 or something like that, whatever, or x squared plus 3. Now, basically, what we're looking at is when we're doing something like this, here is what is factored, right? You take this and you factor it. Now, to find your zeros, what you do is you take your factors and you set each of your factors equal to 0. And then once you have your factors equal to 0, when you solve for your values of x, that's going to be the values of x where your graph crosses. And again, this is not a correct problem. I'm just kind of showing you going through the process. So the zeros, again, are where your function, your output value, or your input value, when the output value is equal to 0. And again, to find the zeros, by factoring, basically you can factor them down. You find your factors, set your factors equal to 0 using the zero product property, and then solve for x. And when each value of x is going to tell you where the graph crosses when your output value is equal to 0. Thanks.